Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's go over the homework. Here are the M&Ms for solving proportions. We got this into your journal yesterday with our lesson, but it's a little bit more in-depth explanation here. The three basic strategies that we use are the giant one, which what happens when you multiply the what do you multiply times the 2 to give you 16? That would be 8. So you multiply the 9 times 8 as well. And what you're doing essentially is you're multiplying this fraction, 9/2, times 1. So you're not changing its value, but you are changing the ratio. So instead of it being 9/2, it becomes some number over 16. 9 times 8 is 72. So your answer for x is 72. The second approach that we talked about yesterday, was undoing division. Since technically this is a division problem here, x divided by 16, you can undo that by multiplying both sides times 16. So it's the reversal of dividing. You multiply, the inverse operation. So x will end up being equal to 9/2 times 16. So you multiply 9 times 16, which is 72. 2 times 1 is 2, and then x ends up being equal to 72. The third process was fraction busters, or what I prefer as cross multiplication. This always works. I highly recommend people use this on a regular basis, where you just cross multiply. 2 times x is 2x. And 16 times 9 is 144. So in the end, you divide each side by 2 and you get your answer. So any of those techniques work. You just decide which works best for you. Here we have some different problems. At first glance, you might look at that and say, ooh, I'm going to cross multiply here. But then if you think about this fraction, 35/70 can be simplified. If you divide the top and bottom by 7, you get 5/10. And so after simplifying it, you can see, oh, a giant 1 will work really well here. 10 times 10 is 100, so 5 times 10 gives you 50. Sometimes it's easy to simplify, sometimes it's not. In a situation like this, I'm not sure that simplifying it would make too much of a difference, although, hey, wait a minute. That simplifies down to 4/11, which means m has to be 4. So there you go. Simplify first and see if that doesn't make your job easier. Here, 12/75, if you divide them by, I believe, 3, you end up with 4/25, and you know, that doesn't really help us too much. So maybe, well, actually, 15, that goes into 75 5 times. So 5 times x is 12. 12 divided by 5 is going to give you x. Use your calculator, and you'll see how that ends up being equal to 2.4. And then in this situation, once again, we can simplify it to 1/8. And now it's just a matter of 1 times 10.5 is 10.5. So 8 times 10.5 will give us our answer. All right, similar figures produce side lengths, corresponding side lengths that are proportional to each other in length. And so we can define these two figures that are similar according to a scale factor. Now, the way to start with the scale factor is start with the two corresponding sides that have the known measurement. So what do you multiply times 3 to give you 15? That number is 5. Now, I would prefer that you write it as 5/1, because that's what you're going to multiply times 8 to get you 17 or to give you y for an answer. So you multiply this times 5, you get y is equal to 40. That was simple enough. But then sometimes when you're going in the other direction, maybe are you supposed to multiply in that direction too? And this is where I've told you in class that when you're going in the larger direction, you multiply times the scale factor that's greater than 1. But if you want to go in the other direction, you can multiply times the reciprocal of that, which is the same thing as dividing. So 38.5 times 1/5 is going to give you x. But then all this turns into is a division problem, and now you have to use your calculator and figure out what is 38 divided by 5. 38.5 divided by 5, and you get 7.7. So that ends up being the answer, 7.7. So I'm a big fan of using this technique. Just treat it as a multiplication problem. When you're going from the smaller shape to the bigger shape, you've got to choose the scale factor that is greater than 1. And when you go from the larger to the smaller, choose the scale factor, its reciprocal, that is less than 1. Here is a 5D process problem, which at first glance looks kind of complicated. And I'm actually noticing something here that I missed in X. So I'm going to put that in right now. Okay, so let's see here. It says during the second week, well, first of all, Andrew just opened a new office supply store. He's been keeping track of his number of customers. During the second week, he had 18 more than he had during his first week. So it seems logical that we would take the first week and be X, and the second week would be X plus 18. Then it says during the third week, he had 4 less than twice the number of customers he had during the second week. Okay, this would have been a lot easier if they would have compared the third week to the first week, but they're comparing it to the second week, so we have to take 4 less than 2 times whatever we had in the second week. So that's going to result in some distributive property. This 2 times X plus 2 times 18, take away the 4, 2X plus 32 ends up being that third week. Here's the second week. Here's the first week. And then they were very kind to us on the fourth week. They just told us it was 92 customers. So, hooray, we don't have to do anything more there. That's this number right there. So the total number of customers is 382. So we're going to combine like terms, then subtract 142 from each side, and then divide by 4. And this answer is X, which is not the answer we're going for. We're trying to figure out how many customers there were the second week. So if this is 60, then the second week would have to be 18 more than that, which would be 78. Now, I don't want to just declare my answer as 78 without double checking that the total that I have is 382. So I'm going to go ahead and double 78 and then take away 4 from that. So 78 times 2 is 156 minus 4. It's 152 for week 3, and week 4 was 92. So let's go ahead and add the 152 to the 92, add that to the 78, then to the 60, and I get 382. Yes, that's what I wanted. Yes, I've just decided my answer was correct, and now I can declare my answer for the second week. He had 78 customers the second week. These problems, I'd rather not go through them unless you need me to, because I have no idea which ones you understand, which ones you don't. I'm going to run out of time here. So if you have any questions about any of these, go ahead and send me an email, and I'll be happy to work them out and send you the response back. Basically, you know, you could probably just add 3/5 to each side here, and that wouldn't be too much trouble. You don't have to do fraction busters. Here, 10.95 subtract 5.2. As long as you line up your decimals, that shouldn't be too much trouble. Here, yeah, just add 3.25, then divide by 2, and then here there's a giant 1. 8 times 2 is 16, so 3 times 2 is X. If I want to quickly pause, back up a little bit, rewatch my explanations, and once again, if it's too fast and not making sense, send me an email and I will give you a more detailed work through on each and every one of those problems that you need me to work through. This is an interesting problem. You might have slightly different answers than me, but let's see where we have common ground. Jessica wants to make a spinner that has all of these following characteristics. So what are the characteristics? There's 4 different colors. I'm going to skip down to this one because this one's kind of important before I go back up to here. It says 50% of the landing space has to be blue or red. And it also says that 50% of the landing space has to be purple or green. So what I did was I just decided 1/2 of my spinner was going to be for the blue and the red, and then the other half is going to be for the purple and the green. So once I cut my spinner in half, now I'm going to look up here. It says it is half as likely to land on blue as red. So there's half as many blues as red. That means if there was 1 blue, there'd have to be 2 reds, right? If there were 4 reds, there'd have to be 2 blues because that's half of that. If there were 6 reds, there'd have to be 3 blues. So I decided to go with this. I made 2 reds and 1 blue. So there's half as many blue as red. And this takes up half of the spinner. Now looking at the purple and green, 3 times as likely to land on purple as on green. So if there was only 1 green, there'd have to be 3 purple, right? Or 2 greens, there would be 6 purple, and so on and so forth. So I stuck with that one, made 3 purples and 1 green, and this is the key. They all have to be equally spaced for this to work. So, you know, this is more of a complicated thinker type of a problem with probability. Good exercise, but if you struggled with it, that's fine. You're not going to be tested on something like this anytime soon. All right, and then the last checkpoint problem. There's a lot of work to be done here, and I'm very, very sorry. The first 2 problems had to do with creating histograms. So looking through problem A, I decided, since the lowest number was 0 and the highest number was 4, that I would have my intervals be by halves. And how many were the 0 bin, how many were in the half bin, how many in the 1, how many in the 1.5, and so on. And then I just created my number line along the bottom to represent all these different intervals, counting by halves. Now, what you may have chosen to do is you may have chosen to lump everything in the 0 to 1 range together. So you would have had one that went up to 6 here. And then lumping all of the 1s to 2s together, this section would have gone all the way up to 8. So yours can be different than mine. They didn't give us any requirements as to how we were going to set up these intervals. At least I don't think they did. I didn't see them up there. No. So there's a little bit of flexibility with how you created this. Same thing applies for the amount of time spent on a math puzzle. I just decided to go 0 to 4, 5 to 9, 10 to 14, and 15 to 19 because the highest number was 19. And all of them would fit into those 4 intervals. And so that's how I set these up. So we're actually counting bin widths of 5. And then the 15 to 19 would be the last one that we would need. We would not need to go into the 20s. For the last 2 problems where we're creating box plots, you had to put all these numbers in order from least to greatest and find the median, the minimum, and the maximums. Label those. There's your minimum, there's your maximum, there's your median, and then the quartiles. They're always the hardest part of this, but the quartiles are just medians of the lower and upper half. So you take every number that's below your median, we've got 4 of them, and find the median of that data, which is the average of those 2 numbers. That's going to be 46.5. Do the same thing in the upper. That's going to be 50.5. And then decide how spread out is this data? What do I need for my number line? Since the minimum is 46 and the maximum is 52, I just decided to count by halves. So there's my 46 for my minimum. There's my 46.5 for my lower quartile. There's my 48 for the median. There is my upper quartile, third quartile, and my maximum. Plot those points underneath the number line and then box in the interquartile range, and you got your box plot. For the second set of data, number of points scored by a basketball team, same idea. Here's your median. You got your minimum, you got your maximum. Your first quartile is the average of 72 and 75. Your upper quartile, third quartile, is your average of 85 and 90. Plot those points on the coordinate grid, then go directly below, not coordinate grid, on a number line. And I decided to count by 2.5s, but I just numbered every 5. And then you just plot those numbers in where you think they should go and box in the interquartile range, and you've got your box plot. So that concludes the last homework that we have of this chapter. Now we're going to spend the next couple of days going over study guides. And on Friday, we're going to take the chapter. So every single day, I will be posting a study guide for you to work on for that day's assignment. The next day, you can look it over like we're doing with the homework. And if you have any questions along the way, feel free to email me. I will respond to you as quickly as I can. Do your best. And then on Friday, when you take the test, you'll have up until Sunday evening to complete it. So take the test when you feel like you're ready. Don't rush into it. And make sure that your notes are thorough and that you've looked over your M&Ms before you start taking the test. Because once you've submitted it, that's your test score. If you want to retake them after that, you can, but you're going to get the scores averaged after that. So good luck on everything. And good job with the work you've done so far. Take care.
Hey, feeling good, like I should. When in dark, walk